using function notation is actually fairly simple. First of all, the idea is that any ordered pair solution to a function fits into a certain particular format. So for example, and I will show you how I got this, say we wanted to determine the output when x is equal to 2. That phrase, while not particularly long, in function notation can be written much more simply as evaluate f of 2. Note that the 2 has taken the place of the x. In this way, function notation is telling us what the x value is, or what to put in to the input of the expression. One of the big differences between using y and using function notation is that when we would simply write y, as soon as we substitute the 2 in for the x and start performing the operations, the information about the 2 is, well, not lost to us, but it's left up here way at the beginning, where it's easy to forget. In function notation, when we continue to write this in each step, it preserves the value of x at each new step for us to see, so we never get a chance to forget what x value led us to where we are. So we evaluate this as you evaluate any expression. We use the order of operations. So 2 squared becomes 4. We can then do the multiplication 2 times 4 and the multiplication 5 times 2. And lastly, we can add and subtract until we get our final results. This here is a single statement that tells us several different things all in one compact little form. It tells us the input value and the output value in the pair. It also tells us that because we know this is a function, we know that that is the only output value. So this here is telling us that the ordered pair 2, 1 is a solution pair to this function, to this equation. Function notation between the phrase evaluate f of 2 being shorter than this instruction and f of 2 equals 1 being shorter than this phrase gives us a more compact way to write the information that we're dealing with. Now, as with all two-variable equations, sometimes we know not the value of one variable, but the value of the other. This is a thing that we will see quite a bit during the semester. But suppose for the same function, suppose we wanted to know the value of x given that the output value is 0. Function notation allows us to say that as well. We can simply say find x given that f of x is equal to 0. Note that we're not being told that x is 0. If we were being told x is 0, then we would have f of 0. Note where the 0 is. It's in where the x goes. This, however, is not where the x goes. This is on the other side of the equal sign. It's telling us the output value is 0, but we don't know what the x is. Not a problem. We use basic concept of substitution to remove f of x and replace it with 0. So please be very careful of this. There is a very big difference between f of 0 and f of x equals 0. One of them is telling you the input value. The other is telling you the output value. Be very careful about that. This equation can then be solved using quadratic techniques, a topic from Algebra 2. Something that, if you feel the need to review, I suggest you do so. There are many ways to solve this, including factoring, if it can be factored, and if you remember how. Completing the square is always an option, although the lead coefficient of 2 makes that a little bit troublesome. There is always the quadratic formula. So whether you use factoring, which can be done, in this case it would be using what's called the AC method, or I would suggest the quadratic formula, one or the other. Both of these will work. And they should give you the same answer, so you only need to do one, of course. I'm a big fan of factoring. I think it takes considerably less space than the quadratic formula, but you do what you are capable of. Again, that lead coefficient of 2 can make the factoring a little bit difficult. But if we do it right, we can split the minus 5x into negative 2x and negative 3x, and then we can do a little bit of factoring by grouping. We separate it into 2 groups of 2 terms each, and from each group remove whatever common factors there are. In this group, we would remove a negative 3. And if it factors correctly, and we did it correctly, then we should see the same binomial factor in each of these pairs. So we can then remove that binomial factor, and whatever's left is the other factor. Each of those can then be set equal to 0. And solved independently. And we get 2 solutions, which again, for a quadratic function, is to be expected. What we have then is f of 3/2 is equal to 0, and f of 1 is equal to 0. Now remember, it is okay in a function to have the same output value be produced twice. As long as the input values are not repeated, then we're safe and we're good to go.